What is going on? Bitwise Guy here, coming to you with the 10th Rust tutorial in the Rust tutorial series. And I would just like to say big thank you to all the people that have been giving me great feedback and all the positive responses and all the new subscribers and stuff. I really thank you, and I really hope that I can keep growing over the next year or so. But anyway, let's get into the tutorial. So, continuing on from where we were last time, which we covered variable size types, I'm going to continue on by reading the Rust book as we always do at the start of one of these tutorials. And then we'll go into some theory here as to what floating point types are, what's a single versus what's a double. And then we'll get into some code to finish it off so I can show you guys the syntax in Rust. So, the book says, Rust also has two floating point types, F32 and F64. These correspond to IEEE-754 single and double precision numbers. So if you're wondering what the IEEE-754 is, it's basically a document that specifies the standard implementation of single and double precision floating point numbers. Okay, so let's get into the difference between single and double precision numbers. In short, without getting into too much complicated detail, a single is a 32-bit word, right? So it's a 32-bit length number, so you can store 32 bits of information is basically what I'm trying to tell you guys. Now, a double is exactly double that. A double is 64 bits of information that can be stored in a double precision type. In our case, we're storing numbers, so it would be a 64-bit floating point number. Now, why is it called a floating point number, and what's the difference between an integer at a technical level? Well, the first thing is that it has an exponential bits. Now, in the case of a double precision, for example, a double is 52 bits significant. So there are 52 significant bits in a floating point double. What that basically means is that after the decimal place, there are 52 bits of relevant information that can be stored in a floating point type that is a double. Now, in Rust's case, it simply implements these in a much simpler way rather than single and double. It implements these in a type called F32 and F64. Simply put, F32 is a single, and F64 is a double. Now, let's get into some code here. If you're interested in some more theory, I'll be putting up a computer science theory class and tutorial series at a later date. But since this is simply covering Rust tutorials and stuff, I don't really plan on including huge amounts of theory into the way that Rust has gone ahead and actually implemented all of these types. But I think it's good and useful to get some background into what's going on here. So as you can see, I've already typed it out once, but I'm just going to go ahead and press that so we can see what's happening. Alright, I'm going to switch over to the other monitor that I've got on here, and we're going to go into our directory as we normally would, which is, I've named floating underscore point underscore types, keeping with the correct, standard of typing things out, camel case and whatever else. And we will go and we'll open up our main.rs. Alright, so as I said, the syntax will be really simple for this. So there are two types, as I already explained. So let's go ahead and write this out. So we'll say let x f32 equal to std f32, and we'll say max, and then we'll say let y f64 equal to std f64 max. And remember from the last tutorial, guys, max is a constant that simply tells us straight off the bat what the maximum size of the type is that can be contained within the integer type of primitives. So we'll go ahead and save that, and we'll compile, and as you can see, we've got two warnings, and it says that these are unused. So the Rust compiler doesn't like variables that are assigned but doesn't actually get used, and the reason for that is simply because that's a waste of memory being allocated if you're never actually going to use the variable. Alright, so let's create two print lines. We'll say print ln, and we'll say x, and we'll say print ln, and then we'll say y, and we'll save that, and sure enough, our warnings go away. So let's go ahead and we'll go back to our first screen here. So we'll swap over there, and I'll just clear the screen for you guys. Whoops. And we'll say reset, we'll clear our terminal here, and we'll say cargo Sorry, first we've got to cd into the directory, so we'll say cd floating point types, and then we'll say cargo run. And sure enough, there you go. So now you can basically see the size of each one. So as you can see, our F32 is much smaller than our F64 size. Now, what are the drawbacks of each one, as I always explain? Now, an F32 really only works on a 32-bit system, and an F64, well, an F64 only works on a 64-bit system. However, a 64-bit system can both accommodate a 32-bit sized floating point type and a 64-bit floating point type. However, a 32-bit system may not accommodate a 64-bit type, because a 64-bit type cannot be addressed on a 32-bit system. Alright, well, thanks for watching, guys. I did say it would be a very short tutorial. Rate, comment, and subscribe if you haven't already. And yeah, thanks for watching. Our next video will be on arrays in Rust.